Hello, hello, hello. Mic testing. हर बार क्या सर आप लोग सर बंद बंद हेलो 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 माइक इज बीइंग टेस्टेड फॉर द टॉक
यूट्यूब लगाया ना
हेलो 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 साउंड कम है ना हेलो माइक इज बीइंग टेस्टेड
चलेगा अभी लगाना बेन
આપણું ઉપર લગાવો છે
અત્યારે લગાવી દી
पूरा नहीं दिख रहा है मिरर सेट करिए सर माइक लगा दो
हाँ हाँ लगा दो બે દૂર દૂર લગાવી એમના નકા ભાઈ ચાલો બે માહિતી
एक और
Oh, Dean. Oh, we came to your room, but that's not. You have okay.
Because I have heard your name from Nirav many a time.
कल चले जाते मंडी के लिए मुझे बात देखी मुझे मन देखी
You were earlier linked with IIT Bombay.
Yes.
Then probably.
Yeah, I was with Sameer also.
With Sameer.
I joined TA for Sameer.
At what time?
87 or 87.
No, we have one of our friends working in MCAPT, the team who was in Samir for some years.
Oh,
But maybe 2000 or 2004.
oh,
2004
I
or
left.
5
I left.
Samir, remember there's a person very famous, I think, who was a reading or somebody who was telling about that, that how mobile phones are bad for.
Oh, oh yeah. Yes.
Heard some of his
Yes. You're right.
Startups becoming entrepreneurs, because I hear things that nearly only a very small fraction of them are successful.
Yeah.
People talk of razor pay and others who are
Yeah.
very big.
Yes.
But what do you think is the
Reason for that? Reason?
What do you think is the reason that
I will show that.
You will show it.
Yes. We have done an analysis on that. Why startups are failing.
I was reading an article
Yes.
on the startup business.
Okay.
It came in some Google feed or
Ah,
something.
yeah.
That talks of most of them fail not because of ideas or something.
Yeah.
Because once they see a little success, they fight among themselves.
Correct.
Normally,
Team.
the team fights. And
Yes,
everybody-
absolutely.
And that has been one major
Yes.
reason.
Correct. You're right. It is very difficult. Like for example, if two founders are there, and there is some, for example, initially some requirement of money, I will put. If the other person is not putting, then the problem starts. Then I will think why I have to have him as a co-founder.
In fact, a few years back, even Indigo had this problem.
Yeah.
Both of them are fighting
Yes,
like anything.
yes.
You know, the media was making news out of it.
News about that, right?
I was discussing and I'm also very enthusiastic, like making, if we make something in the lab, it should go as a product.
Yes.
And but I do face a lot of problems. Some I try to overcome, but single person handling it is very difficult.
Team is required.
Yeah. So, but then I know that no matter what you put in, at the end, system has to.
Plasma Research, IPR Shuttle Incubation Center, and the HPNI's Innovation Institute Innovation Council welcome you all. And we also extend our warm welcome to Dr. Suresh Nair, our esteemed guest for today's talk. I'll give a brief introduction about Dr. Suresh Nair. Dr. Suresh Nair is an esteemed alumnus of IIT Bombay and a serial entrepreneur, stands at the forefront of innovative product design and technology development. As a visionary founder of Design Alpha, he has dedicated himself to nurturing entrepreneurs in critical sectors such as health, environment, agriculture, and education. Design Alpha, with a strategic investment, got transitioned to Amara Raja Design Alpha, providing concept to product development services. Dr. Nair is also the founder of Biophoton Technologies, engaged in healthcare products. With an unwavering belief in the potent synergy between the academia and industry, which is very important to all of us, Dr. Nair emerges as a guiding force in the realm of new technology advancements. From his humble beginnings at Samir, the R&D lab of the Ministry of IT, to his tenure as Chief Technology Officer of NEST, a multinational company, Dr. Nair consistently spearheads innovative progress. His passion for knowledge dissemination knows no bounds, exemplified by his extensive contributions, 107 publications, 18 patents, 2 authored books, and over 200 technical reports. His recent book, Product Sense, is widely accepted even as a textbook in universities. Dr. Suresh Nair stands not only as an innovator and a mentor, but also as a true luminary in the realm of technology and development, product development. Dr. Nair serves as a chairman and member of various Government of India committees, one recent being the chairman of National Center for Quantum Accelerator Chip using lithium niobate, led by IIT Kharagpur. He is also an active member and holds committee positions in IEEE, right? Yeah. So I would request Dr. Nair to resume with his talk on Can Researcher Be a Good Entrepreneur? Thank you.
So good morning. Good morning. Okay, thank you very much. Thank you very much for having me here. I am nervous to talk to all these esteemed scientists here, and thanks to Dr. Neerav also for inviting me here. And it's always a pleasure to talk to scientists. I will have very short presentation. You can ask any questions in between. So the title is Can Researcher Be a Good Entrepreneur? So you can decide the answer later on. Okay. So with all your permission, I will start. Give me a clap first. You know the reason for this? I am coming from industry. Industry always looks for return on investment. My investment today is talk. So my return I expect is only clap, but I want it at the earliest. That is what the industry looks for. And also you need not have any shame in asking that. Okay, there is no problem in that one. So that is the first lesson today. Okay. So and also you can continue to do so whenever you feel like. Okay, so no boundaries on that. So today's outline of the talk is like science, technology and product. I think all researchers, they know this one, but still I wanted to stress on that. What is the importance of science, technology and product? Then why should you become an entrepreneur? That is very important. You know, you will be asking, I am a scientist, I am doing well, why should I become an entrepreneur? Then next one will be, how will I get good ideas? So that also I will explain. Then technology readiness levels, you know, you are, almost every day you are dealing with that, but I have seen some, some aspects which we have to stress upon. Then these are all general, but I will take you through some case studies from my career. So that will be very interesting, so that, research translated to commercial products, how it was done. Innovation translated to multi-million dollar business, how it was done. How to create market for your idea or innovation. So these three things I will cover. These are real case studies, no bluffing there. And product development life cycle. If you have an idea, how to convert that into a commercial product. Normally we think like whatever we make in the lab as a proto is the product, but I will explain what are the things. And some of the products developed recently from my lab, I will just show without revealing the IP and things like that, and I will close with this one. Okay. The first one is this, most of the science happening in whether, fundamental research organization like TAFR and all. We joined together in TAFR. And the output what we are expecting is international publications like in Nature and things like that. The output from this science research should go to applied research. That is the technology side where it comes. Where you are expecting patents, copyrights and also publication. I think probably you may be in both. So that should not stop there. That technology from that applied research should get to convert it to a usable equipment or product. Then only you are giving a real service to the society. Even though we are all having a lot of publications, all that will add value to our resume only, not to the society, right? So if then the society, what happens is like it is translated to an industry, because you may not be able to do that. Then the industry will make money, and then what he does, this also we have to understand. Normally, fundamental research all are funded, government funding, taxpayers' money, okay? And the output goes to the applied research, again government funding. Now government has, requested like some industry funding also should happen, so that it is serious, okay? Then for industry, no funding, it's our own funding. We have to get some dowry or whatever it is and then do our own funding there. So there is no government funding there. So then what we do is we make products, we sell them, make money, and also we pay tax. So this tax goes to again back to the government for again government funding, again research funding. This is the closed loop. This we should not disrupt at any time. I think about engineers, about closed loop, how it works and all. So this closed loop has to be there. So we all three have to work together. This is the point which I want to emphasize. I think this, but that is why now most of the government projects in many of the committees I am there, they are always insisting like a industry partner is there from the beginning. Otherwise, you develop everything, there is nobody to take over. So that happens. Little bit about me, I think why you should become an entrepreneur, I have to tell. I joined, Samir, that was a TAFR that time. TAFR, the beautiful place, very nice West Canteen, East Canteen and all those things we were enjoying nicely. So there is no problem. It's a sort of sought after position there or as a scientist. So it was a comfortable job for me. And also even if you don't, we got some 120 publications and all. Then in government, don't take it in the offensive mode. It's just a jovial type of thing. Even if you don't perform in a government organization, what happens? Your promotion will be delayed by 1 or 2 years or 3 years. That's all. What is going to happen, right? So there was one person, I will give some stories also to make you listen. There was one person who was not performing and he was not getting promotion for 3-4 years and all. Finally, he also got fed up, and the management, their senior, they know that he is not performing, he doesn't come on time and things like that. Finally, this fellow goes to his head, says like, anyway, you are not giving promotion to me. So why don't you, I will leave, because there is no way here I can survive. You give me a recommendation letter saying like, whatever it is. So the head was okay, this fellow is anyway leaving, my disturbance is gone. He has given a thing like, this fellow is very good, very active in all the work. That's how we give. We don't tell that he is not working. So what he did was like, in the next promotion, he submitted that letter. Okay, so the director himself has told that I am very good, hardworking. Why you are not giving me promotion? So for the juniors, you can take it, and directors and at that level, you can be very cautious on that. Sincere recommendation. Again, my first phase, Samir TFR was over. Then I changed my job to an industry. It's at that point of time, joining an industry is a risk. We don't know whether they will pay, because I am getting very good salary here, government salary, government position and all. So I have taken a risk there. So I will take these points. I will consolidate those points. So I joined a corporate where I took a risk and joined as DGM at that time, and I became global CTO. And there were a lot of public patents and publications and all. I was very good. So luckily the company was doing good. I could do lot of things, and lot of hefty package, everything, car, everything is there. A very luxurious life in that way, but lot of tension because you have to bring business. The company has to grow. That is okay. Then again I took a decision that I should leave this. Okay, it was very nice, comfortable job, but still I left and I started a company called Design Alpha. A few more companies are there, but I will focus on Design Alpha. And now, it was my entrepreneurial journey in my 50s, when I was in the age of 50. So those who are old, gray hair and all, don't worry. Age is not a limit to start any company or entrepreneurship. Okay, that is what I want to tell. I started the entrepreneurship in my 50s. Now I am running in 40s. Because every year you put entrepreneurship effort, your age will come down. You can find that out, okay? So that is how it is. And what happens when you sell your shares? I sold my shares also. You can go to Maldives with the family and enjoy and all. So you have to be an entrepreneur, okay? So I am trying to convince. And also, when you sell shares and you can produce movie also. I did that one. And so people say that when your star is not in your favor, you start doing all these things. Anyway, that is how it is happening. So the point which I want to, it is not to show my, me in these photos and all, but the point which I want to make is, to become an entrepreneur, what you need to do is move out of the comfort zone. You have seen my government job, I moved out. Industry, it was very nice. I moved out. And when you become an entrepreneur, you don't have sleepless nights. So how to pay 40 lakhs, 50 lakhs per month to the employees? From where? If the building is not there, what will I do? I'm not so rich to get every time from my family. So that is how it is. But if you want to really become an entrepreneur, you have to move out of the comfort zone. Okay, that is what. Why? I will tell that also very clearly. Then you will ask me, how will I get good idea? Because to become an entrepreneur, you have to have an idea, right? If I know that, I would have done it, right? Anyway, so I saw this picture. You might have also seen 3 apples that changed the whole life, the whole world. First one is Adam and Eve in Athens. I think you know that. Second one is Isaac Newton. Gravitational law came because of Apple. Third one, Steve Jobs. Apple, everybody is using Apple phone and all. So after looking at this picture, I thought like if I have to have some innovative idea, I have to do something with Apple. That's what I inferred. Okay, so not to blame me. So that is how I dreamed. But I am a Mallu, I am staying in Kerala only. So I don't have apple or anything like that, only coconuts there. So if I apply the same technology, then I will go and die under the tree. So this is, I thought like this idea will not work. Okay, so don't follow as such other things. Okay, you have to think something differently. Then you may ask me, then how will I get good ideas? See, I will not get into all these things, but focusing only on India, because you are mostly looking at the Indian society and all. There are a lot of challenges available and opportunities available. I try to put some of them here. As a scientist or engineer, how can you take up this challenge and use these opportunities? That's what you have to think. Okay, so I will simplify this one. For example, if you look at various domains, agriculture and rural development, youngsters are thinking like Swiggy is giving the food. If you have money, you get the food, right? I am not very sure whether youngsters are knowing that this has to be grown somewhere. There are farmers who are struggling, and then we are eating that. I think that information is not there, at least for IT, guys, the new guys. They think like if money is there, we will get. So I always used to tell that, and the youngsters, many don't want to get into agriculture because that is a dirty job type of thing. We always want white collar jobs and things like that. So I always used to tell like if the farmers stop giving anything outside, then we all will be starving and dying, right? Even though we have money. So nothing is good. So as an engineer or scientist, how can you bring some contribution in agriculture without dirtying your legs and hands and all? You can contribute. You can come up with new ideas. You can see, for example, drones are there now. The same thing, remotely controlled machine can be deployed. You can come up with all those ideas and deploy it. So you need to sit somewhere very nicely and do all farming. You can do that. So like that, water environment, I think some of you are working on that. Lot of people in Northeast, arsenic content, lot of work is going on. I think scientists are all contributing towards that one. So that one, then women's safety, what all we can do. I think it was very prior this thing earlier. So how can you do that? Waste management, sanitation, very, very important. I think probably plasma, maybe, I think you may be working on some of these areas. The idea here is like how can we contribute through our knowledge, science, technology to the society. So that is what we have to look at. Sanitation, I will just explain, like the sanitary napkin or, all these things are, everywhere. People don't know what to do. The other things we can make compost and things like that, but these plastic things and all, what to do. And you won't believe one woman, I tell you, one lady, she came up with a idea of sanitary napkin which will dissolve at 50 degree or 55 degrees Celsius. So it gets dissolved in the water itself. That is the type of, I think you might have heard a lot many innovations are happening. That is what we have to think on that. And similarly, I can look at in healthcare. Healthcare is one of my favorite subject. We have come up with a lot of things in this. How can your knowledge get translated into healthcare products? I will tell you like how to translate the science and technology to product. Then livelihoods, clean energy, of course, lot of work going on. Physical disability, we are all lucky, we have everything like hands, legs and nose, eyes and everything we can see. But there are a lot of people who are not having, unable to hear, unable to see. So as a scientist engineer, how can you contribute so that those society will also get benefited? That is what is required actually, even though we are doing a lot many things, but that at least some portion of our work should be towards societal activities here. The sensors, I think I will skip here. I always used to tell like, lot of opportunities are, these are some of the opportunities where still it has not come up to this level. For example, which food is the best food? When our mother makes, that is the best food, right? All agree? That is the taste we like. Till marriage. After that, you should not tell that. Okay, whatever your wife makes, okay, that is a good food. Anyway, and also we like junk food, right? Because of the aroma, the taste, even though it may not be healthy. So I was thinking like using science, can't you sense and detect the things and all and come up with a mother-made type of food with good aroma? It's possible. I think scientists can do that. I think a lot of sensing activities are going on. So we can do on that. Other one is, another idea in my mind was like the IoT. Now everywhere IoT is there. We buy some dress, for example, sari, online. But when it comes, we feel like, oh, this is not the thing which I thought. Because I was not having, or I could not feel that, right? So that also using haptic sensors and all, sitting remotely, you can really feel and then buy. I think then Amazon will stop the return scheme. So that is how it is. So a lot of the ideas are there. Okay, only thing is somebody has to, focus on these things. Now coming to the innovation. Everybody we talks about, this is a process of translating an idea or invention into a product or service. That is what normally innovation. But I have modified the definition. I call it as an innovation only when process of translating an idea or invention into a product or service for which customers will pay. This is very important for scientists also. See, when we do MTech, PhD and specifically focusing on in some area, we will think like we will come up with some product with this knowledge and there will be a customer. This is the wrong notion. That is what we feel, but there is no customer there. So because you are fully biased in your subject, in your area, you will tell, you can see the proposal, this can be applied here, this can be applied here, all those things dreaming. There is no real customer. That's why I put customer who will pay. Pay means he is the real customer. If you ask some people, they will tell, I will use it, but if you tell them to buy, they will not buy. So you have to identify this very real customer. I will take you through a jovial thing. When recently I fell down, I broke my hand and I had to put some implant and all. So I put a plaster. When we go out, you have to tell everyone what happened. They will ask kya hua, like that. So I was fed up. Like you are spending that much of energy to explain. Instead of that, no, my innovation is like this. I came up with a sling. I put a reason for my failure on that one. For example, the first one is dog bite. Second one is, I fell down from the stairs. Third one is game, sports and all. The fourth one is family problem, which I don't want to, like if you get a hurt in your head and all, you may get, you don't want. So that is a simple way. No, I need not tell anything. It automatically happened. Okay. So you can clap wherever you it applies to you. Now coming to the technology readiness level, this is, very well, I know you people know that. But you normally think like technology readiness level is only one streamline like that from idea to product, but it is not like that. This is very interesting. Like as technology readiness level grows, there are activities in everything, even in research. So that's what normally we don't think. Like when it reaches technology level 4 and all, we will think like research is over. It's not like that. This is very interesting to make it very simple. What normally you follow, the 9 technology readiness levels are there. Why I am showing this is like whenever some proposal comes, they will tell like we are at technology level 3, we will go to 8. To the government proposal. I don't really believe that. Actually, it is, we are just telling we will reach 8. It is not possible. So, normally your proposals and all will start from 2 or 3 and it will reach maybe 4 or maximum 5. That's what you have to put in. So, we need to really, there was a question.
Actually what happens is, when the scientists conceive their ideas,
Yes.
they assume that this is going to work.
Yeah.
Right? So they consider that it ho gaya.
Ho gaya.
Already
Yeah.
functional requirements are met.
Absolutely,
So it will
absolutely.
be TRL9, nothing
Right.
more than that.
Right.
So here the perspective as to why
Yes.
you can enlighten.
I will surely. I will see I will take you through some product development life cycle. Then you will know actually. See, for example, whatever you do in your lab, I will show that also some examples. That is only basic principles and maybe technology concept like using your equipment like spectrometer or whatever you use, power supply, MATLAB, everything you just show it. That is only the technology concept is only formulated like that. Then it has to go through the critical proof of concept. You have to prove to others. It's not that you are saying like this is working. It has to be proven to others independently. Then component breadboard validation in laboratory environment you have to make. Then in relevant environment, for example, this will be underwater. So you have to show, you have to test it in underwater. It's not like saying that it is underwater. So like that it goes on. Prototype demonstration, then operational environment, actual system completed and operationally qualified through test and demonstration. It's a big process. Very difficult to, it's a long process. I'm not telling very difficult. Then the actual system proven through successful practical use. For example, anything for space, it has to be tested in space, then only you will become 9. So that is what normally in the lab itself, we call it as 8, 7, 8 and all. So this has to be understood. These are all, available information also.
One question.
Yeah, please.
Even if we reach say 8, 7 or 8, or or even 9.
Yeah.
But then there is a problem that supposing somebody is buying some standard product, so and that's an imported one.
Yeah.
Now to convince people,
Yeah.
although some major people must have used it, but to convince them that this is now in the country, developed in the country.
Yeah.
But it is very difficult, for them to accept it. And even if they see
Yeah.
it is working, how to relate
Yeah.
that and how to, convince people in that
Correct.
regard is also
Absolutely. I fully agree. There is a systematic process for that. I will show that one. I will show. So now I told all fundamental fundas only. Now I have to show the real case studies. Okay, with government institutes only. You may be knowing CGCRI. I can take their name. They are very good in optical fiber. That too with specialty fibers. They put terbium doping and a lot many things, rare earth material doping in the fiber. So here those who are not very familiar with optical thing, like normally in our electrical thing, in communication, for example, when the signal becomes weak, what we do is we amplify that and again put it back. In optical, what is done is like when optical signals are becoming weak because there is attenuation, that is first converted to electrical. Then it is reconstructed in the electrical domain, then it is put back to the optical thing. That is how it is happening. A media conversion happens. Instead of that, EDF, erbium doped fiber, when it came, you need not really bring that optical to electrical. You can amplify in the optical domain itself using this EDF, erbium doped fiber. So this EDF, the CGCRI was very excellent. They have a lot of research and they have come up with the EDF fiber which was there in their lab, and I happen to be a research council member. So during my visit, I told them that why don't we convert that into a product, I think which is applicable to this thing also. Then they told me, yeah, we can give only EDF, you do whatever you want. So we undertook that. EDF, you cannot sell like that. You can sell, but it's not possible to get market. So what you have to do is you have to give or design the associated things. So only the EDF what I am showing there, that is the only part made by CGCRI where a lot of research has been done. What we have done is we have designed all other things like that because it has to be temperature controlled, otherwise wavelength shift will come, and all those things we have done. And we came up with this system. You can see the round one, what you are seeing, this is what is given by them, but we made all other things like mechanical, it should look like a standard product. You can see all testing and a lot of requirements are, all those things are done. Then what happens is we received that CSIR award for EDF. It came as a front page CSIR news. Like I was at Nest at that time, CGCRI Nest produced the market. We could sell in US. So only thing is like what my request is like, you have to identify the right industry or right partner who will help you, because you cannot do everything and I cannot do R&D. So that same way, complementing. So that is how it is possible, and we could come up with this thing. So the reason for this can be called as a technology transfer. I'm not very sure, but why this became successful, that also I have to explain to you. Theoretical strong background for example, if I want to change, if I tell that my amplification is not happening, they will do an analysis and come up with a different design, whatever design iteration. They are very strong in that. Large pool of scientists to support any time, dedicated their own manufacturing facility to supply us EDF, because the EDF is being made there. Normally research organization, they will make one and stop there. Here, since I have a lot of market, they have to continuously run that thing. So they have done that. Any customization, they have supported, participated in cost reduction programs and sustenance and all. We have beaten the Chinese competition. This is, I have to tell that story also, when the cable TV people were buying some EDFA. Now we are having all fiber optic, all the signals coming through optical fiber. We could not get into the market because of Chinese thing, okay? Don't take it outside. So the problem is like, for example, my product cost around 600 rupees or something like that. I'm just giving a number. They are giving for 300 rupees and one free. if you buy one free also. So I was thinking why they are giving free, and I had a discussion with them. They are saying like if it doesn't work, you use the other one. So the cable TV operator, they don't know really how it is working and things like that. So it was a challenge for me. I went to China, to find out what is the thing. So what they are doing is like when they are making any component, there is a specification. For example, I will take a simple component coupler, fiber optic coupler, 50-50, 3 dB coupler. So what in our lab also we are doing that. What we are doing is an automated process we have done, so that the fiber is twisted and drawn, and when it is 50-50, it will stop there. So sometimes during packaging and all, it may change from 48 to 52 or 47 to 53 and all. We will throw it out. What Chinese are doing is like they are also having this problem. They put it in another bin. It's not like throwing out. So this is actually a zero cost for them. It's a waste actually, okay? But we don't have any idea to find out exactly how much, because it works in cable TV. So that is how they are able to find that out. Yeah, please sir, please.
A large pool of scientists to support, and then the number is the revenue for them.
Yeah, the revenue is like for every product sold, we will buy that fiber for cost. We have agreed for the cost. For example, per meter, maybe 100 rupees or whatever it is, we will pay them.
You pay to CGCRI?
We will pay to CGCRI.
Or it is to the scientists get selling?
No. I think it is to CGCRI only. CGCRI. Our agreement is with CGCRI only. And for every product sold, we will give a royalty also in addition to that one. So that, it encouraging people to do that. So so this is very interesting. I also have a failure of technology transfer also. I have to tell both the things so that you will understand what are the issues with that. Here the main reason, I will not tell which lab. Successful labs we can tell, but the failure lab I should not tell. It did not work. We got the technology transfer, but in our industry we recreated, it did not work. Reason, only the research student was having all ideas and he left after his PhD. That is the normal thing. Normally the supervisor will not, they don't have time to really look into all those things. So what you have to do is like documentation. Laboratory book and documentation, even though we hate documentation, but this is a must actually. Okay, the knowledge should not go with the people. Knowledge should be with the lab. So that is one thing. Yet all data left the organization when the researcher left, along with the researcher. Only he knows. Then we try to contact him also, it was no documentation available. Possibility, I am not telling, some data manipulation also happened like that, because we are unable to recreate the same thing. He was not coming back and all. I should not blame, but we are just, no working prototype was available in the lab also for reference. For example, if you want to see, you want to check, there is nothing. They tell like only this is there, we have 2-3 patents, so you take that patents and go. So that is what, it's very, very thing. So you have to be very, very careful on this thing. Then research translated to commercial products, another one. This will be interesting to you, I think Dr. Neera was also talking about that. Forget about the domain and all, I may be more focusing on optical, healthcare and all those things. This was a oral cancer detection system. In cancer detection, the early detection is the cure. That's what we believe. Other things and all, chemo, surgery and all those things are okay. But early detection is the cure. You can do many things. Lot of, people have surpassed that issue. So there was, we were focusing on optical oral cancer. So instead of taking biopsy and all, can you use optical light and then shine in the mouth, and at that time itself it can detect, like using, here the principle used is diffused reflectance. Yeah. So that is what is, I am not getting into all those things. I just wanted to tell you some ideas here. So that was the proof of concept, like, available spectrometer I used, tungsten halogen lamp with a lot of wide spectrum we used. Then optical fiber we designed some of them. So that way we have used. But this is only proof of concept. Now, from this, I am not going to use all the wavelength. I know this is the wavelength I have to use. So I will select that wavelength. Spectrometer, spectrometer is expensive. You cannot put that in a device. So only the detector, detecting at that wavelength you have to use. So that is how I converted that into a design. That's how it is. Whatever LEDs we are using, then transimpedance amplifier, ADC. So all those proof of concept we converted into a design type of thing. Okay, this design you can see that is converted into a small module. Otherwise, spectrometer, laptop, and everything occupying one full table, that is converted into a small module. We call it as a light engine, where LED comes from here, then filters, detectors, everything is done. This is what we have to do as an engine design. So this is very important. Then only you can come up with the product. This was the old proto, where the probe is there. You just shine in the mouth, and on the display you can see various things like healthy tissue or precancerous or cancerous, like that. You convert it into that one. That is how it has to be done. So whatever idea you have to first do the design, then convert it into a product there.
What kind of accuracy you will talk for that?
Sensitivity and specificity was around 90 or above 90 it was. Yeah, it is being used now. Yeah.
Sir, one thing.
Yeah, please.
With the product.
Yeah, show me. Yes.
This particular product, how much, you have the electronics and controls, everything inside.
Everything inside.
So how much of that electronics or components are available in the country, and how much you get it from China?
See, make in India, absolutely no ICs. But what we are doing, all the mechanical light engine design and manufacturing done here, all other things are except the components. Components means resistor and capacitor, we can get it here. But otherwise, all ICs, microcontroller, everything we have to now import. We are using that. But all PCB, everything all done here. Yeah, that challenge is still there. I think government has understood that. Another one is innovation translated to multi-million business. Very interesting. It's actually a motivational thing, not when fiber to the home was coming up. I think it is 16, 17 years back. It's an old one. I cannot show all news stories, So at that time, the fiber to the home was coming in US, and there is a network company, Verizon. They are one of the major people. They invited a lot of people. They gave a problem, like they have a multi-storied building. They wanted people to come up with a solution which will be very fast and reliable, okay, and low cost, of course. So that is what was done, and out of that there was one requirement. You may be knowing the optical fiber connector, the loss in that one. Typical loss is the empty connector. Empty connector means in one fiber itself you can have 12 fiber. One connector itself 12 fiber, or one ferrule itself 12 fibers are there. That was the technology. Now it is very popular. So we were not really knowing. We have never worked on that, and they told us, like, you come for a meeting. They have given a specification. I think the 0.3 dB insertion loss and 65 dB return loss, or something like that. Nobody has realized that one. So we got an idea. We went to US, and we have a lot of people in US also. They took us. I was actually as CTO. I have to go and present. Their requirement was like this. I could not sleep for a few nights, because if I go and tell that I can achieve this, they can think like I am bluffing, because I have not done that. How are you saying that it is? And nobody has achieved that. If I tell that no, I cannot achieve this one, I may achieve maybe 0.5 dB and 60 dB, then they can tell like, okay, you are not qualifying our requirement, you can go out. So both ways I had risk. Finally, one night I got a spark, and I went and told the committee that if a company like Verizon is demanding 0.3 dB and 65 dB, it should be realizable. I take it as a challenge. I will do. That's how he told. So they cannot really, because they have only put the spec. If it is not realizable, they cannot tell that, no, it is not realizable. Then that's a wrong thing. So that's how I took that challenge. I came back and developed, I think, 1.5 years, a continuous development. We got the business there. And nobody else has achieved this one. Why I'm saying is like, if you have idea and you are a leader, true leader, Indian brain can develop all these things. I think they are very successful. This is a very volume manufacturing product now. So that is how it is. It is possible like that. I have a lot of patents in this process, because US people are always looking at, how these people are doing. So I had to patent, but not the process. I did not fight the patent for the process, because I have to keep some secret with me. So that is how they are buying from us now. Yeah, even Japanese people. Another one case study, I don't know whether it is boring, but these are all my personal, so that you can take it as a real story. Created market for this is a very interesting thing. Again on optical only, because when you read any textbook on optical thing, why optical communication is required, you will see this one, high signal security. That's why defense and all are using optical fiber communication, because you use copper, they can tap it. In wireless, if you have a wide band receiver, you can tap it. Of course, there will be a encoding and all those things are there, but people have made it an encryption. People can always decode that one. So that is not this thing. But if you take a fiber and bend like this and give some normal laser light, at the end the light comes, but when the fiber is bent also, you can see some light there. Normally we don't really look at this one, light aa raha hai bas. But this has sparked in our head, saying like, even in optical fiber, if you are able to create a bend, light can be leaked out and tapped. This was the idea which we came up with this one at that time. It was a challenging idea. We went to, and people will ask, I think those who are knowing the link design and all, whenever we are designing any link, we give a link margin. Even if I step on the fiber, the link should work. So link margin, for example, around 10 dB link margin we give in microwave communication as well as in optical communication, so that even if a vehicle passes over that, the link should not disrupt. So that much link, that can be misused. So even if a 10 dB type of power is taken out, your link will work without any problem. You will not know that somebody is intruding. So that was the challenge, and it has been happening. And we went with this idea, we developed some product and went to Indian army. They took us to some place, I don't know where it is, with no board and all, you may be knowing. So there they told me, this is the link, this is the server, this is the user. I will send a file, you intrude and show me. That was the challenge. I thought like, if I am not showing, then I will be. So I told them, don't encrypt anything, just send a normal file. So they sent a file and we intruded and showed in our laptop, it was a picture of a tank. They were surprised. They told them, how it is possible, it's an optical fiber and all. That's all, it is possible like that. So then they believed it, and it went to a lot of very, very high levels and all. And they asked us, can you give that? So that we can go and find out in some other network whether what is going on. So we told, we are not intruder, we are actually intrusion proof people. Okay, so we have come up with a system which can, this is like that, sensitivity data, whatever it is, one copy I can get it. So we came up with something like this system. This can identify any intrusion in a network. It can tell where it is with a 50-meter resolution, and when intrusion is detected, it can even send some junk data to the intruded path, so that people will remain there. Because if you shut down the signal, they may go to the next fiber. So we will continue to give some junk data so that they will remain there. They can identify where it is and things like that. So these are some of the things. Only from a fiber bend we could get that spark, and you won't believe, I think most of the Indian defense networks are covering this one. We sold a lot many things, many products to them. Now, madam, I think somebody, sir, was asking about the startup ecosystem. Many startups now, 58,000 in India. We are knowing about the successful startups, right? We don't know what is happening into the unsuccessful one. So we did a postmortem on the failed startups. That is very important. You have to learn, why it is. You see that top 20 reasons for failure is no market need, 42%. I told you in my first slide, I am very good in my subject, I will come up with a product, but there is no market need. So that is what is the main one, 42. Ran out of cash. Whenever you get some money, you use it, and not the right team. I think somebody was telling about, because the team, it is not like my brother-in-law, sister-in-law will be the founders actually. You have to select the team so that it complements, okay? Then get out-competed. It takes years and years and years, and nobody wants that. Only everything you want 1 year is the maximum you can get to show a product. That's how Birac and all, I am in the member in that committee, 1.5 years. 18 months is the time given to them. Pricing cost issues, I will come to that, poor product, like that. Many, these will not add up to 100 because there are cumulative reasons also. That's why it is not adding up to 100. So we have to learn from failure. So the customer, you need to really know. So if you have an idea, I have created a self-check. You yourself can do a self-check. Originality of the idea. Is it like, you can see that many people read some IEEE paper and come up with their own idea. It is my idea. Because the review members will not read everything. They will not know everything. They get funding also. But you are putting your life into risk. So you have to have originality. Originality doesn't mean that non-existent. It can be incremental originality. Just adding a little bit on that. Okay, that is what the second one. Before starting, you have to know, the prior art status. Till now, what has been done in this area. So it is not to reinvent the wheel. You have to stand on their shoulder and look further. That is what is required. For example, somebody has done something. Okay, they have done, but something else I can do. That is how it is. So you have to know what has been done till now. Patentability, of course, market analysis, competitors. So you may not be able to do. There will be some business development people who can do all these things for you. Development cost and time, it is, if it takes some 100 crores and 5 years and all, very risky unless you are very rich. Product cost, this is very important. How you know the product cost? You design the product, you make all the bill of material, you put the cost, and then you know what is the bill of material cost, then you add many things like, I will show that. That is how product cost. It is not. My theory is like when you are coming up with the specification initially, your specification, wavelength is like this, power is like this, sensitivity like that, you add the last one, should be product cost, or the product cost what it should be. For example, if you are coming up with a mobile phone and a lot of good ideas, like it can do heart rate monitoring, this monitoring, that monitoring, but it is costing 2 lakhs, who will buy? We are a new person. If iPhone comes with the 2 lakhs or 5 lakhs, people will buy. So you have to know how much should be the cost of the final product. That how it comes, you have to have an idea, like for example, you are developing something, ultrasound machine. So what is the present cost, and my cost will be like that, little less or something like comparable like that. Why this is required? Your design can be tuned to meet that. You can cut down some of the features. You can identify some unwanted thing. You can find out some low cost version. One example I don't know whether we have time, but I will just explain. Somebody came up with a Japanese customer. They approached us for a identifier for bike. Now we have identifier for our car. When we press key, that sound comes and that is a car opens. But if you go to a railway station, thousands of bikes are there. When you keep your bike, you don't know which bike is yours. Very difficult, all looking same. So they thought like if you are able to come up with a small identifier for bike also, that will help. They told it the cost should be 600 rupees, not more than that. Nobody will buy above 600 rupees. The car, I think it may be 5,000 rupees or something like that. So when we looked at the solution, we have some chip which we can use, but it will go to some 1,000 rupees. So we have what we have done is we started from transistor, made an oscillator ourselves with a coil, then we realized that one instead of using the available this thing. Repeatability, that is another one. In the lab only you can show. If you tell somebody else to demonstrate, it may not work also. It is like that. We are making like that. It's your baby and you love that one. You know how to do it and things like that. So that should not be. Repeatability and manufacturability. Design is done by PhD and all, but the manufacturing who is going to do? The technician. They are maybe ITI. They don't remember Maxwell's laws or any other laws, whatever you are V equal to IR and all those things, formula and all, they don't know. What they are going to do is you tell them what to do, they will do. For example, you take a resistor and put it there, they will do. So if an amplifier is made and it should not oscillate when you put all those resistors. So the design has to be made in such a way that when a layman is assembling it, it should work. So that's a design for manufacturability. Okay. There are another thing, the interest in selling idea. I don't want to get into all these things. I have only idea. Can you sell idea? This is also possible. There are some ways to do that. You have to have a working prototype. You have to product features and all you have to make. Your products market you have to know. Then prepare target parties. You can identify somebody, and you may need a help of a negotiator, good negotiator, because you don't know what is the cost of your technology. The cost for technology, value for technology will come only when it is sold in large number, right? You don't know. So that's a problem. You can take help of some of the people who are knowledgeable in this area. So basically, as academicians or professors or researchers, we worship Saraswati. But when you get into entrepreneurship, you have to start thinking Lakshmi. But for Gujarati people, I need not talk about that. But that is how it is. You have to always think in that domain. What should be the cost and things like that. I believe in women empowerment here also. I did not go to Krishna, Shiva and all those things. Okay, so now the very important thing, product development life cycle. This is very important for you. Whatever you make in the lab is sort of a concept. Okay, from that you have to show the proof of concept to others, saying like, see, this works. Okay, once that is done, then you move on to a design. At that time you have to think like, this is going to be my final product, even though it will not be, but you have to think like that. And the design will consist of electric design, electronic design, industrial design. It should look good. It should be a mechanical design. Then all these things will be there. How a user should use it, how they are going to use it. Depending on that, you have to design. Then you make the proto, the first one, alpha proto you can call it. Then you test it. There will be surely a lot of problems. Or you try to get some feedback from customer also. They will give a lot of things. One of the things what I hear is like, when I ask a customer, can you buy this? They will tell, see, this is black color. If it is red, I would have bought 100. But I don't have red, right? Because that is the type of excuse it comes. So proto is built, corrections are made, beta proto is made once more. That's all. No gamma or anything like that. Then you make a pilot build. The pilot build should happen in the industry or a place where your volume build is going to happen. Okay, that is what pilot build. Why? There are reasons for that. I will explain. Then compliance testing. Whatever product you are coming up with, it has to be complied with the standards like CE, UL, whatever your safety standards and things like that. It has to be complied testing. Then reliability testing. You are coming up with a product. You have to give warranty for 5 years or 10 years. It's a new product for you. How can you give warranty? How can you? Because you have not used it for 10 years. So only way is to go to a Jolsier and you show your kundali and ask him how much I can give. That is the only way, right? No, it's not like that. There are scientific ways like highly accelerated life test. You subject your product to highly accelerated environment. For example, temperature cycling. I used to tell like you take the product and put in the pressure cooker and burn it. That means 85 degrees Celsius, 85% RH, burn it and take it up and see whether it still works. And you can put in an oven, you may be having a lot of temperature cycling. You can take data continuously. From that also you can derive statistically what can be the life of the product. Okay, this is one way. Otherwise, you have to just give them. So I don't know whether we have time, but I will just show one simple thing. I have shown all these things, but I have to show a few slides. See, the concept let us avoid. Proof of concept, that is how it was done. It was done on, it is an ultrasound machine. I will show only the console because the other thing is very clumsy. So the console, a new type of console was coming up. So we made the proof of concept on the table, like evaluation boards and all those things. Then we go for the design. The design involved all those things. I wanted to show particularly this design. This was the design of the console. You can see here a rubber sheet there. Normally the design doesn't require that. But when you are doing the design, you have to see what all things going to happen with this device. Because this will be used in a radiology lab or by a doctor or a technician. There is a possibility of the gel. Normally when you do ultrasound, you will use the gel. The gel can fall, water can fall, coffee can fall, but still your product should work. So we made a rubber sheet here so that even if it falls, it will not get onto the electronic board. It will get drained to other part.
So this thing comes under the
design
feature or the patent feature?
Design feature. So then, like that we have to think of all those. One more example, those who are mechanical, you will know that when ultrasound is being used, the technician or doctor will be using this knob always like that, So they will put lot of pressure. So this is the area where lot of pressure is being given. Then my mechanical design should not, sort of bend or warp there. So in order to avoid that, what I can do is increase the thickness of the material. That is a wrong way of engineering. Instead of that, you can put some ribs. Some ribs can still increase the strength of the material. So when you design the mechanical, you have to put some strips. So these are all, unknown things, untold things. When you do the design, you have to take care of that. So that we did, and a proto, a 3D printed type of thing. It's a proto, the first one. Then we made the pilot build. The beta proto also looks something same. Pilot build in the lab, so it looks like that, the final product. And the compliance testing, you can see. So many things we have done. This is what normally we don't really see. Cleaner, wiping, whether the color goes or anything happens to the circuit, all those things, disinfectant, whatever is being done in the actual life, that has to be repeated like that. Then reliability testing like that, we have come up with a setup to, one simple example I will tell you, when you are designing a product, you have an on-off switch. Normally, I don't know where we will put it, we will put it at the front because it's a very good lighting. So that position also is a part of ergonomics, where you want people to use very often, or you don't want people to use very often. If this will be used very often, you can put at the front, very nice, otherwise put at the back only. Okay, then how will you select the switch? We are not going to make a switch. You have to estimate how many times this product will be switched on every day, approximately 4 times. Okay, how many times in a month? 4 into maybe 25, 100. How many years? You are giving warranty for 5 years. So into 5. That means it may be coming to 1 million times I will switch on and off. So when you select the switch, you have to select in that way. Otherwise, the whole system will break down only because of the small switch there. So this concept you have to take care of that. When you transfer, that is another thing I think somebody was asking. You have everything. You are not going to sit with the manufacturer to give all details. You have to transfer everything through documentation. Documentation is a big thing. You have to, because you are conveying everything to not the technology, but how to do to the manufacturer through this way. So that is how, the product what we made was a bulky. At that time, this was existing. We designed a new one like. Yeah, please.
So I think that whatever you show, that is a linear process, but it might not be because
yeah. Correct.
Find something in reality test and then you have to change it.
Right. This is a very ideal condition like that. Right? You are right. We have done that. So I will close it with a few products which we have, just to sort of bring in some spark in you. We have been working with many customers, both domestic as well as multinational. In medtech area, I told you that is one of my favorite area. We have come up with a lot of ideas, a lot of engineering we have done. For example, eyes, I will take 1 or 2 without revealing the IP. Eyes, like one of the major eye hospital in India, they give these medicine. And the patients come back saying like after 2 weeks they will tell like nothing, kuch nahi hua, kuch improvement nahi hua. So it was a problem actually. So what they have wanted was like they want to monitor whether these people are using this medicine. So they have that idea, and we have come up with a smart medicine box with 2 bottles of medicine they can keep, and it will identify at what time they are taking it out. It will give alarm to the patient to take this the time. And when they take it and put it back also, it knows if they are not using. All this data is given to the hospital also whenever they require. So that has given a very good idea, because these hospitals are coming up with very innovative medicines also. So they want to really monitor whether it helps. Yeah, this was the old one, but So from here, what they made was like that. It's a dabba, they made it. And this is what the design what we made it. Another person, they made like this one. It's a kidney, the urine monitoring system, automatic monitoring system, how we design. Because see, nobody is going to buy these things. So unless you create, so like that we are working with the cancer detection, all the many startups with very great ideas. They are very successful. in getting money, getting investment after showing all these protos and all. I will not take you, and many of the IITs are working with us in various things. This is one thing which may be of interest to you. This is actually handling these, for the CT, you give the radioisotope, right? Something like that, the dye. So that we came up with a system which will automatically do the sharing of these dye to the vials and things like that. And many new things are.
That product which is on the bottom.
Yeah, very interesting. This one?
Yeah.
Yeah, very interesting. See, whenever a new baby is born, normally it will have jaundice, yellow color, or even if it is not there, they will, for us it will look like that. So this baby is taken to the NICU, and how the baby is there, they blindfold, because the UV light is put on them. It's around 460 something nanometer. Light is put on the baby, because so they blindfold. If a mother or father sees from outside, it will be very, very difficult to see them. And also, so we came up with an idea. It's our own product. Our own product means we gave it to somebody in medical. We used the LED and we made a fiber bundle, and we made a sort of a blanket, fiber blanket. So this blanket can be used to wrap the baby. So you need not put light from here, it is just a ramp. So that this device is a very small one. The baby need not be taken away from mother. It can be with the mother, and this light also. It is very accessible. I think many of the hospitals you can see this. It is already implemented. It's a little expensive, so people are a little reluctant, because the LED, just like that you put it. So this is very interesting thing. Many, like interesting for your interest. I don't know, many are interested. And this one is paddy grain quality. How how to find out? You have to do husking like that. You remove that outer cover, and then they will tell what is the quality of that one, like Andhra and other places. So we came up with a system where you just put the grain, it will fit on the groove, and we shine some light, and then from that itself we can find out whether any breaking or in the grain, and what is the quality. From it can find out the sensing like that. So like that, many water recycling also for one of the startup, from washing machine, that water is taken, and I think you may be knowing some of them. Special Braille printer, A4 size printer, we developed for a Canadian customer. MIT is the soil testing system. They have the electrodes design is done by them, but they are remaining done by us. The soft robotic gripper is for Harvard University. We have made maybe some 500 numbers to them. It's a special purpose robotic grip which can be used with the glass and all. So those are some of the things. I will not get into the Peltier energy. I think you are all maybe working on. We have designed a vaccine carrier using Peltier energy, so that the battery operated vaccine has to be kept between 4 to 7 degrees Celsius. So that is how we made it. So everything is there with my book. I think you should buy that. Product sense, one copy is given to director. So that's what I have. So as a summary, anyone can be an entrepreneur. I think you have to move out of the comfort zone. That is the only thing. You have to have that perseverance, like you will win. And that's what you have to decide to move out of your comfort zone. That is the only thing. Need to have determination, patience, and perseverance. May need good hands-on mentoring. Mentoring is very important. Everybody is not expert in everything. So some people have got some idea on engineering and all those things, product cost, business development. Business development is very, very important. How to sell the product, satisfaction, giving back to the society. That's what we are doing, and this has to be. So yeah, the last slide, the Socrates. The Socrates, like the great Greek philosopher. He used to give lot of long talks to his friends, very long, because he's a philosopher. Finally, Socrates was poisoned and killed by his own friends. So I will stop here. Thank you very much, and I will be very glad to answer, because I don't know what is the requirement from your side, whether you liked it. Yeah.
So,
yeah.
Question.
Yeah.
You were pointing out during the presentation.
Yeah.
How important
Yes.
is determination of the product cost?
Yeah.
Right?
Yeah.
To be a factor of deterrent
Yeah.
to for an innovator
Yeah.
to decide whether to go further,
Yeah.
or not? Or maybe there are certain ideas which might come to fruition from the market or commercial point of view, maybe in say 3-4 years time.
Right.
But you have to start developing or start building the building blocks of it.
Yeah.
So is product cost always the factor once innovator has to decide and then move forward with this idea?
Yeah, see, up to some extent, because when you do the design and all, you will not really know what is the product cost, because when you go for volume, it will come down like 40% and all when the volume goes up. So that you can consider. The second one is, once you are very confident of selling this product, you can also have some means of value engineering in cost reduction. When you are about to reach the product release, you can focus on cost reduction. That is also there. People are doing that. It will not be a complete deterrent there. Yeah, please.
He is one of our startup.
Pardon?
He is one of our startup.
Oh, okay. Oh, very good.
Thank you for a nice presentation. I enjoyed it. But you said something that for entrepreneurship you have to come out of your comfort zone. So do you think that when you are doing research, you are always in your comfort zone? That is one question.
Yeah.
Second one is that if every researcher becomes an entrepreneur, then there will be no researchers.
Yeah.
So how many percentage you think that what should be the weighted average in terms of that how many should become for a development of the country as a whole?
Absolutely, very good question. Researcher need not be always on the comfort zone, but when you start working on in one area, I think that is the comfort zone. That is what you will become actually, because you don't want to get into the other one, because you are doing again research on the same thing. So that is one thing, comfort zone you can call it. The other one, what you have sold, but see, only very few are interested in entrepreneurship. Even now, even after a few years, I'm not telling like everybody will become an entrepreneur, but only a part of those people will be interested in entrepreneurship. So, and you cannot really come to an entrepreneurship without idea also, without research also. I'm forgetting about all the research done on that one. Like for example, diffuse reflectance. A lot of research is done based on that only. So, but you can still convert that at least to a product, or you find out somebody who will take it that also. That is also a thing. It should reach the society. That is the idea behind that one. What you are told is right.
Can I add something?
Yeah.
Great question, Garib. I just would like to share one conversation which I had with Dr. Anil Kane, who has been on various things. He's a known entity. So I was just having a conversation. I asked him that we have seen a lot of collectors coming in Surat. Right? So there was one collector who came and made a big difference that today Surat is a different city. So what was the difference? Were the rules? Were the culture? Everything was the same. So he said that the only element which is required to outperform even within this thing is zeal. And zeal comes only when somebody steps out of the comfort zone. So even for a researcher, you don't need to be an entrepreneur. But to try out something new, आप कुछ भी नया लाओगे ना, there will be 100 people saying ये नहीं चलेगा, right? So that itself is one type of entrepreneurship, not necessarily to be business one.
Yeah, correct, absolutely.
Yeah.
Yes.
There is a very fast changing world.
Yeah.
AI and other things, people are taking their help, and any entrepreneur who is going to start in the beginning, there are 100 other people are also working in this single line. So what do you think about that? Entrepreneurs should always have the team of researchers with them, because its products are changing very fast. Others can bring better products in no time. So
you are right. But I showed you in one slide the originality, the incremental originality. That is only to you, and you believe that will hit them, compared to the other product. But that has to be there. Always the research has to continue, and because one product, meanwhile, when you develop, you may see that something similar is there. So there are risks there, but your team has to continuously work on that one. Yeah. See, for example, vaccine carrier, when we developed for somebody, they were only one. But immediately when they found the COVID market, then a lot many people came up with this one. So you have to have some IP always improved on that. Yes. Many questions are there. Yeah.
Thank you, Dr. Nair, for this motivating talk. And I'm sure that some of us will be motivated to become entrepreneurs.
Oh, okay, thank you.
If they are above 50 or below 50.
You will become 40.
My question is, you mentioned that from the basic science to the applied science and to the product. So, if from the concept to the product, it needs to the basically lab to land. But before going to the lab to land, we have to know the market size. Market size. Whether really the society needs it or not.
Correct.
In the TRL, where it sits, that market size.
TRL doesn't mean, I think TRL is only that development thing, it happens there. Just 1 minute, let me see whether there is one.
It talks about the applicability of the concept.
Just 1 minute. I have
3 or 4, because 4, 5 and 6 are where the product
right.
supposed to be validated.
Let me just see whether any specific thing is there. That's a good question.
But
market doesn't actually really, this is only. See, when you make a business model, there it is there. For example, 1 minute. See, the second one, interaction with the users, designers, engineers, it goes up to 9. The second one. Market opportunities also goes up to 9. It's a parallel process which you have to continue. What I have shown, the next one is a simplified one only for the developers or designers. But all these activities are there for TRL levels. How it goes with that one.
But as a researcher, he knows that it has a potential to become a product.
Yeah.
But whether that product will survive in the market or not.
Market research has to be done. You have to, whenever when you are presenting any idea, people will ask how many, for example, you are coming up with the healthcare market. How many doctors have you met? That is the first question they are going to ask. It is not only idea. You have to do that background work before starting that one. See, if you tell that 500 doctors or 100 doctors I have met, we will give very good weightage because he has done his homework. It is not, that's what I am telling, the market customer need has to be identified. It's not like I am thinking like it will be sold.
It is a part of a business plan.
Yeah, business plan is there, business plan. I can show that business plan also, where you have to, when you start any activity, you have to fill up, I think Stanford business model if you see.
Researcher will do or
researcher only. You are going to become an entrepreneur, then you have to only do.
So I think it is the first step of the design thinking, because you have to be immediately.
Yeah.
You have to have unity, then you start solving the problem.
Yes. Problem has to be identified first. See, for example, when you start, I have not shown that. Stanford University, I have actually taken a course there. Business model is there. They will ask us to fill each one of them. So you will find you cannot fill that out. Because unless you do a lot of work, you can fill up some of the technical thing, but not all of them. Like who will be your customer? Then who will be your vendor, how the channel comes, all those details we have to fill up. There is a big matrix you have to fill that out. At that time you will be very clear on that, what you are going to do.
So product will be very fine, but it cannot be popular to reach the common people.
Yes.
So that's basically planning for that.
Yes. See, you have to be very careful on that. Like, every product need not reach all the common people. It can be a scientific product to be sold to lab also, but you have to know that there is a requirement for that.
Sir,
yeah, please.
idea
mat bolna.
अपना ऑक्सीजन मीटर हम लोग मेजर करते हैं उसमें शुगर मॉनिटरिंग आता है सिस्टम जो हम लगा दे उंगली पर किसी ने बनाया है या हम बना सकते हैं दैट विल बी huge market for these things and we are facing continuously and testing sugar on that and by putting the
pricking
finger in the equipment they can measure their sugar level
right so it's
I'm highly interested in that so if it is already there
it is a lot of the non-invasive glucose monitoring is has been going on for quite a long time actually. Even we worked with some of the Yeah, you can. But we made something because this is the place. Earlobe is the best place to get the thing. So we came up with small thing which will clamp onto this one. But with temperature, with skin, lot of problems are there. Even now, research is going on. Startups are claiming. Some people have already claimed. I was there in committee where they claim with what is that, some RF monitoring or something like that. They have come up with that. But till now I have not seen marketed product from India.
So,
yeah, there is a lot of opportunity. Yes. Any idea if you have which is very reliable, I think there is a market. Yeah.
I know a study of a PhD student
Yeah.
in one of the institute where he had studied the sweat sensing for the student.
Yeah.
Put your finger, whatever sweat traces are there.
Sweat, then these saliva, all those things are there. But
somebody knows physics side, they knows, and then requirement in the medical side also.
Yeah. See this, in BIG grant, every time people come up with this one, but nobody has solved, as far as I know, with a reliable device. They are saying that is in the stage 2, stage 3 and all, but I have not seen.
So how can we proceed for that?
Now, what is the idea behind that? You have to first show it in the lab. Then if it is proven, then you can surely put it as in BIG grant, you can get 50 lakhs for that.
Thank you.
Sir,
Yes.
So our country is more of a trading company, trading economics.
Yeah.
So the only bottleneck for us is mostly the Chinese products. All across, be it a small chip or whatever.
Correct.
Machinery is coming from China.
Yeah.
What could be the strategy in the Chinese market?
I don't have any. Yeah, see, we have to, the government of India is doing it everything, I think, Atmanirbhar type of thing. Even in defense, I think they are focusing first on defense. Defense, lot of opportunities are there, like they are trying to replace one by one in this one with a new idea.
Chinese actually did it long back.
It is still going on. It's a very, very strong.
Did it long back, replacing the European market.
I don't know whether I can tell all those reasons, whether it should not go out. Like, see, US professors who are doing very good, Chinese professors, they will go back to China every time. Okay? But Indian, we don't do. We believe in ethics, actually. We don't bring some technology from US, since an Indian professor, he will come and show here. Not like that, but this is happening. So many of the things, whatever happening in advanced research are already there in China.
So another 50 years.
Another I think it's, I'm not very sure about that. But but awareness has come now. People have to, get into every area.
Government is taking a lot of steps to restrict the import and
Yes.
but still we are coming up with MI.
Absolutely. You cannot.
That various clauses are coming up.
See, by US customers also now they are, some of them are moving out from that place to other places like Vietnam, Philippines and all. The manufacturing, they know this one. But there are, see, one example I will tell you. If I have to make a mechanical tool here, it will take maybe 3 months minimum. And after that also they will delay, saying like Diwali ho gaya, wo ho gaya karke. So they will delay it. But in China, if you give it, within maybe 1 week they will get it. Because they have a infrastructure already ready. But only thing is like, initial.
They also have a big market.
Yeah.
They globally do the marketing.
Yes.
Apparently we are a failure in that.
Correct. But you have to.
We have a product, but we do not have the market.
Right.
Even though within
So the strategy what we use is.
I think the madam's question was the similar line. We build the product.
Yeah.
We build the product, but we don't trust our product.
Oh, correct.
We don't trust.
But if you really go through these steps, what I have shown, it will be automatically working because there are many products now. Yeah, a lot of questions. Yeah.
I have a question.
Yeah.
Do you think such a startup has a good potential which will independently scrutinize any technology transferable or innovation idea being put forward by a researcher that can be evaluated by that startup? Checklist.
But customer will not like that. researcher will not like that. So see, the business happens on personal terms only. It's not on mostly on business this thing. So
the researcher's fund is funding somebody. So that
if the researcher agrees, then correct. You are right. But that is not required. If you are very sincere on the research thing, it can be helpful.
that is the measure.
But you are asking about a startup which will do evaluation of this one.
The issue is that if I am very sincere, I have attachment with my research.
Yeah.
That's why I get misled. So it is very important. There should be a third commercial innovative.
Possibility is there. Possibility, but the customer should like it. That is the problem. Yeah, you have one question here. Yeah.
Thank you for the presentation. I have, in the entire product life cycle of any kind of product, specifically for a hardware product, there are some avenues even beyond after the product has been developed, like after sales, market penetration, distribution, and also how do you deal with the lead times for various electronics?
Yes.
As you mentioned, most high-end electronics are not available.
Correct.
And they can have quite lead times, and design changes can be very expensive.
Yes.
So how to deal with that?
Yeah, this is a normal process only. See, for example, once the design is done, your requirement is there from a customer, like you have to 100 numbers you have to supply, but the components are not available. So you have to deal with them. There are many ways, like for example, through distributor you can go. So sometimes they have some reserve with them. If you are not getting from the original supplier. So you can go to the distributor also. Otherwise, for any company there is a team there, supply chain management team, who always looks at where is the component, did you place order, where is it now, he will call, then how it is coming, freight charges, customs clearance, all those things. There is a team, supply chain management team is there. They will take care of that one. Their job is to do that. Your question is like that, or?
The question
Okay.
is that for specialized electronics,
Yeah.
there can be some components which are not available.
Yeah.
Like, for recent example, NVIDIA came up with a series of NVIDIA Jetson Nano,
Yes.
which was edge AI devices.
Yes.
And they suddenly ran out within a year or so.
Yeah.
So for the companies who would have built on that, the companies stopped.
Correct. See, when you do a design, no, what you are telling is correct. See, when you are doing the design, you have to really also understand whether I will continuously get these products, these components. That is a part of that design itself. If you think like it is not available after some time, then you are gone. Yeah.
I think it is more of a supply chain problem.
Yeah, supply chain problem.
The only alternative that you have is you have multiple chains. You don't need to rely on one particular thing. If you rely on one thing, then you definitely will save.
See, for example, when we do the design, when you do the design, we write the bill of material. We will always write to more than one supplier there, like that.
So how do we deal with distribution, sales, marketing? Because that is also one of the key avenues.
Yeah.
You can have an excellent product, but you have to also
Absolutely. That business development is very, very important. They are the first one to go and open the door.
So my question is that supposing there is a technology which is available in the world since ages, decades, but it is not there in the country, but is finding a lot of applications, and one develops it in the lab, goes to the product stage as well. Now, the thing is that the vision goes that it should be used in every nook and corner where the technology is required, and it requires a lot of effort.
Yeah.
But that team is not there right now with you. And slowly it will happen that with whatever zeal, etc., one makes it, that remains in the lab after that person who has put in so much of zeal gets over with the job, etc. So here the country fails, like you have everything, but then it still did not reach. How to solve this? But supposing the person doesn't want to be an entrepreneur, but wants to search for a good entrepreneur.
There are many ways actually. If you are not having enough muscle power to set up a sales team, and you can sell the idea also. So there are industries who are, I will show some, I think I have not put, there are a few industries who are willing to take your technology and take it up. So you will get it will reach the society and you will get a royalty also in this one. For example, I was the chairman of one of the committee which developed a breast cancer detection system. It's a CMET, you may be knowing. CMET is in, not Pune, actually Thrissur. So they developed it. I was the chair of the committee. Actually, I used to be very tough with this committee, this thing. The only idea is it has to reach an industry. It has reached, they have transferred to 2 companies and the companies are now volume producing. So they are getting the royalty. So you can identify some people who can take it further also.
Yes, sir. At times it happens that the technology has many fronts, right? From the concept design.
Yeah, that has to be done.
Now, single company, very few companies are there which have all this set up to really deliver that product.
No, madam, this will get into a domain. See, you have to tell which domain you are. So the companies are focusing on, for example, healthcare domain, industrial domain, defense domain, agriculture domain. Like that, you have to specifically tell what your product is going to work in. You cannot tell actually all. Then there are companies who are targeted. There are companies who are willing to take up the technology like that. Yes.
I have a product developed in our lab and we have conceptualized it and it has market. We have supplied to 15 places in India. It's a digitizer, like you have text X-rays. Not all the places have digital X-rays. There are still places where they use the film. So we have conceptualized in our lab.
So this is from this film you are digitizing.
Yeah.
But will it have market when the digitized X-rays are there?
No, not all the places.
Where the
digital X-rays are very costly. Even the scanners are very costly. They come around more than 2 lakhs. We have supplied to 15 places in India. We are having an AI project on TV. So in that they have lots of retrospective X-rays where they wanted to digitize it and give it to us as a data. So that is how the need came to us. And we developed in IPR. We used the fabrication party to fabricate it and we have given to the 15 places. But somehow we couldn't patent it. So now the concept is with us and everything is there. The software is there, the hardware is there, and it is applicable in the health sector and also in other industries.
You can discuss with the people, ma'am. There are many healthcare companies who started.
We have limitations of entering into the market and
no.
people, so that little bit of design.
We'll try to figure that out.
So this is one of the.
See, for example, from IIT Delhi, IIT Madras, and all products have come out. Actually, these people have taken over. Right?
That's the reason we invited him.
You have to identify the right people. That's all.
We gave it within 30,000 to all the places. And the professional scanner comes more than 2 lakhs.
2 lakhs.
There is an issue of maintainability.
So at least where X-ray is there.
We can continue the conversation later, so that now I would request Dr. S. Mukherjee, Dean of the Institute, to please give a token of appreciation.
Thank you, sir. Thank you. It was very nice. Okay. Thank you very much. Thank you. Thank you for inviting.
Thank you very much, sir, for your valuable talk. So we will try to have a visit to your lab so that we can discuss what can be done.
Yes.
Thank you very much. Special thanks to your outreach team for these efforts, for live streaming this. Thank you very much. And